Okay, so the last thing in terms of equations is conjugate root theorem. Right, so we talked about Dumois theorem, z to the n equals, etc. We're now looking at the last little thing, which is conjugate root theorem. Very simple theorem. If you have a polynomial, this is the emphasis, real coefficients, okay? Z cubed, 4z squared, 3z, 10. Every number is real. And they tell you a factor. And they will always tell you a factor. Because that's complex, and the original equation was full of real numbers, you needed a partner to wipe out. Because I've got this thing with i's in it, it has to multiply by somebody else with i's in it, so the i's disappear, because there were no i's in the original equation. That's all conjugate root theorem says. If you give me one, I automatically know the other factor. Okay? So in an example like this, it's z cubed. That means I'm looking for three factors, or three solutions. They gave me one. Therefore, I know the other one. So you've already got a mark. Because 3 minus 2i is a solution, that means 3 plus 2i has to be a solution. Yeah? That's what conjugate root theorem states. Everyone happy with that? Just find the conjugate. Therefore, write it out, z minus. I actually put this in little brackets here so that we don't stuff up our algebra. Z minus the factor. Don't worry about signs, don't do anything except go z minus. And in the second bracket, z minus the other factor. 3 plus 2y. They're both factors. They gave you one in the question, you wrote it in z minus form. The conjugate is already there because that's what the root theorem says, and you write it in factor form. Happy with that? Expand. That's the same as z minus 3 plus 2i. Z minus 3 minus 2i. All I did was get rid of those little brackets now, remembering to multiply through by the negatives. The reason I did that, look at it. This little term is there, and this little term is there. So basically, it's an a plus b, a minus b. Every time we do this, it'll be like that. It's the difference of two squares. So that's the same as z minus 3 squared. There's your a minus b. Expand that, z squared minus 6z plus 9, 2i squared, 2i all squared, sorry, is 4i squared, but I squared is negative 1, so the negative basically makes it plus 4. Right? You got your 9, and this becomes a plus 4. So there's your quadratic factor. I haven't done anything with this yet, I'm just getting my quadratic factor because of the information they gave us. Yep. Therefore, z squared minus 6z plus 13 times somebody else has to give me this thing here. Now this is easy inspection, none of the thing like we did the other day, the bridge. This is obvious. If I've got z squared and I need z cubed, that's z. And 13 times somebody has to be negative 13. That somebody is minus 1. What's the question? Ask you finally, fully factorise, write out the factors. You could have got that the last lesson that we did, but you would have started with finding factor 1 first. Do you know what I mean? Because if you had no information, you would have to try 1, -1, etc. And then you would have done this. Here, they were generous enough to give us factor number 1. You know factor number 2 because of conjugate root theorem, and you only had to find the missing value. Jason, yeah? Only works for real coefficients. That's the biggest thing to take out of this. And you say, well, what is that? If I showed you something like that, it's gone. And I told you that 3 plus I is a factor. I've just made this up so it won't be. That doesn't work. Okay? It doesn't work. As soon as you see an I anywhere in your polynomial, forget conjugate root theorem. Doesn't work. That's the key. Conjugate root theorem only works real coefficients. So I've emphasised the real. Okay, so that's the one thing there. That's equations. When you're going through in your cheat sheet in your head, conjugate root. What happens this time is you're actually talking about a random variable z rather than 8 points. So far we've dealt z is 3 plus 2i. It's just been a dot. Now we're going to deal with relationships between a random variable z and a particular point. So it's like a journey. A locus is just the equation that you're travelling on. And that's my journey, my path. So whenever you see this, z minus something in a magnitude, that represents the distance from z, which is a variable point, wherever I am in the room, and a set point. Right? So if I'm z and x plus yi is our little doobie thing there, the camera thing there, right? As I move around, I'm a set distance from that point, right? And it's moving with me. What am I doing? What's my journey going to be if I managed at this distance to walk all the way around? The distance between me and the camera and Quinn running away from the camera. Follow him. Thanks, it's his soul being sat down.
Why are you running?
What's the journey? What path am I walking on? I'm always the same distance from the camera. A circle. That's all that's saying there. The distance between me and the fixed point, which is that thing or anything else, is r. If that distance between us is always the same thing, then you have a circle of radius r and centre a plus b. Where I was there, that pivotal thing there, that represented the centre of the circle. And the distance that I move around is the radius. Is everyone happy with that? Interpreting that. This is what they're going to look like, the problems that we have. Okay? Sketch and describe S, the set such that Z is a variable so that the magnitude of Z minus 2 is always equal to 3. It will get to a point that you know what that means straight away. Okay? And you'll be able to write that answer down. In fact, some of you might be able to write the answer down straight away. What's the equation of that? What's my path? when I edit this, I'll put some music in the background over these moments of silence, uncomfortable silence.
So did you say that x plus y
Yeah, but what does that represent? If I said to you, z minus 2 bar is 3,
the magnitude is z minus 2. The magnitude is z minus 2, isn't it?
The magnitude of z minus 2 is equal to 3.
So that should equal 5. Z should equal 5. No?
No.
What are we trying to find?
I want to know what the story
is. It. Oh.
Yeah. 3 is the radius. What's my picture? What have I got? Straight line, a circle, a parabola. It's a circle. And where's the centre? 2 what? 2 comma 2 0. So boom, 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 2. There's your picture. And that radius there, 3, 3, 3, 3, 3, right. That's what that says.
How is it a circle?
Okay. How is that a circle? You doubt me.
No, I didn't know.
You do doubt me. That's okay. So, we don't know that. First time you've seen it, you don't know that. All right? I've mentioned this here because I walked around my thing, but you don't still see that strong. So, you're in an exam situation, you're in a question situation, you don't know. We rewrite this question. Z minus 2 magnitude equals 3. What is Z?
Z is a complex number?
It's a complex number. Perfect. What is a complex number? How do I write a complex number down?
X plus y.
Beautiful. So, I replace my Z with x plus yi. Right? So when in trouble with these things, all you do is replace your z with x plus yi. Cool? Keep working. This is a real thing, just x. This is real. So I'm just going to put them together, make my little reals go together. And then I'm going to write yi equals 3. Yep. What does magnitude mean? How do I find the magnitude of things?
X squared plus y squared root.
Yeah, square root of the thing. Yeah, magnitude is basically the hypotenuse, which is basically Pythagoras, which is square everybody and then root the whole lot. Bang, bang, bang. Yeah. Every time you see magnitude, you can rewrite magnitude in this form. Square root, the real component squared, the imaginary component squared. No, don't put the I in. Equals 3. At the moment. Yeah? Bye-bye, square root. By square root. Have you ever seen that form before? What is it?
Circle.
A circle with radius 3 and centre 2, 0. 2, 0, 3.
So how do you know that it equals 3? I mean, you know it equals 3. How do you know that's a radius?
Oh, anything in this form. Anything in this form here. Right? Because what Z, and back again to here. Z represents me. That represents a point sitting there. So R is my distance. So if I take myself 2 hand spans away from there, and it doesn't matter what I do, I'm always 2 hand spans away from there. I'm trapped. It's like the old, stick a collar around the dog and put a pin in the middle of the yard, and he can only run around in circles. Right? Can't get further away because he's got the leash. Can go inside, and that becomes, if they start doing inequalities. So if I actually turned around and made this, and you had to draw it, you would colour the whole circle in, because I can walk in and out, but I can't walk further than the length of the rope. Does that make sense? So you have a choice. You start recognising these things, and we just go bang, thank you very much, give me the answer. Or you do this journey, x plus yi business. The x plus I will always work. especially when we start getting, and you'll see the next example I do goes to about 3 boards worth. It's great algebra, love it. Right? Not this one, the one after that. But this is your basic one, recognising, and in a multiple choice quite often they'll have, that represents a circle of radius 9, of radius 3, of radius 81, and they'll just muck around with the 3 and the 9 and the centres. You just got to remember, in this form, that number there is the radius. You don't have to square it, you don't have to square root it, it's the radius. Okay, automatically in that form. Arc. What the hell is arc? Angle. Thank you. So all I'm saying to you is, this little, let's forget the -1 for the moment. If I said to you, arc of z is pi on 4, let's picture that. I'm saying, doesn't matter where I am, relative, let's go back to our little family camera, relative to that, doesn't matter where I travel, I always am on an angle of pi on 4. What's my journey? Where am I travelling? Trace my path, what would you get? Circle, parabola, straight line, butterfly. Straight line. Yeah? Doesn't matter what I do, I'm always 45 degrees compared to that point. That's what that's saying. Is it a line? Do you know what a line is?
It's just a straight drawing.
It's a straight drawing, good. Thank you, don't be scared. Okay, let's go right back to geometry. What do you know about straight things? What sort of things are there?
Lines.
There's lines, there's intervals,
Lines.
there's rays. Do any of these mean anything to you? Are they any different? What's an interval? Yeah? Or it's just, basically it's got a start and end point, yes? What's a line?
Line's endless.
It goes on forever and ever. What's a ray?
Well, it's not endless. It starts at one point.
Yeah, so it's like an arrow thing. Good. So, if we were drawing it, we would draw a ray, not a line. Why not? Why can't I draw it down here?
That won't be pi before.
It won't be pi 4 as an angle, right? Because you are measuring from here. So I go up. And I just create an angle of pi on 4. There's my picture. I've already drawn the picture. I need to worry about an equation, but we'll do that in a second. There's a very, very, very important thing to emphasise in this. What do I do here at 0? Do I draw a black dot, which means I'm in, or do I draw an open dot, which means I'm not in? Arguments for the defence, or arguments for the prosecution. Who says black? Full black dot.
So is that how it looks?
That's how it looks.
Because it's z -1. It shouldn't.
Not yet. Yeah, slowly. Foundations. Yeah, we'll do the one in a second. I'm more important about the ray. The emphasis of the ray. Who goes for an open dot? You have to make a decision. Open dot? Why? Yeah. If I stood on the camera right now, I haven't created an angle. Yeah? So if I'm at the origin, I haven't created an angle. As soon as I step 1 millimetre out, the camera follows me. 45 degrees. 2 steps out, 3 steps out, etc. That's what this is talking about. Now, exactly, all we do now, because of the -1, what does the -1 do?
Translate it.
Translation. Like we do in methods, you're going to be sick to death of these translations. Everything you do is bloody translation, translation, dilation. Right? Same business. So we now turn around and move it to 1 with an open dot and create an angle pi over 4. So this is arg z pi on 4. This is arg z minus 1. Just a translation. What do we care about? The open dot. Very important. Okay? Because when you start, you can't make an angle till you move out and I look at you. Then I'm creating it. You've got to find the equation for this. Okay. Straight line equation. What do I care about in a straight line equation?
Gradient.
Gradient. Beautiful. What's the gradient? Gradient is 1. Y of tan of pi on 4 is 1. So there's my angle. And you remember tan beta equals m. That's another very important piece of information. Your gradient is always equal to tan of theta. Therefore, m is 1. What else do I need? Y-intercept, yeah? Which you can't really tell, but basically, if you're in the form y equals mx plus c, you know the gradient's 1. We pick a point here. That point is x is 1 and y is 0 plus c. So c is negative 1. So my equation is x minus 1. Is that it? Done? True? Is that the equation? Does that show me that? Limit the domain. Well done. X is bigger than 1. Because it's a ray. If you only put it that way, it's a line, which means it goes both ways. So you find your equation, y equals mx plus c, and you put your little domain restriction in. Okay, this one we'll have to record because this one I'm telling you, you'll probably go over again in the recording. But anyone like to have a stab in the dark of what that picture would look like?
Quadratic. Quadratic.
You're saying that the distance between me and a point -2, yeah? And the distance between me and a point -1, so let's pretend we've got a row of tables here, and that's 0, that's -1, and that's +2. So the distance between me, Filio, me and Daniil is always 9. Whatever way you go, it'll be a total distance of 9. What have I done? What's my journey? What's my path? Can you picture it? No? Ellipse. Ellipse? Well done. Well done. Couldn't see it? Not used to it? Let's prove. Step 1. When in trouble, replace your Z's. Okay? Every time you can do this, replace your Z. Step 2, partner people. Real, real, imaginary, imaginary. X plus 2 plus y I. No, make it straight. X plus 1 plus y I. 9. Please just yell out once you've lost. We've partnered. Next step, get rid of magnitude signs. To get rid of magnitude signs, we put Square roots in. X plus 2 squared plus y squared I squared. X plus 1 squared plus y squared I squared. I don't need the I squared. What am I doing? Sorry. Okay. See? Fall into habit. Don't need the I squared because that'll trans things over. It's just magnitudes. Next step.
Squaring both sides.
Square both sides. Divide by 9. We're going to square both sides. Are we happy to square both sides? Alan, no? Come on. Don't, because I don't want to write all this stuff and go on camera if it's wrong. So, do we square both sides? Does anyone see an issue with squaring both sides?
Is it addition in the middle?
Hmm?
So you can't really square both sides?
Yeah, you can't square both sides, can you? Because how many people would just square this and then square that? No one owns up to it. Good. Right? Because think of, you've actually got A plus B. Yeah? There are two terms here. So if I want to square A plus B, I have to do this. Yeah? And if you do that, you get A squared. That's good, because if I square this by square root, I'm happy. Then you get 2AB, which is 2 times this root times that root, which is pretty ugly. Square root. Then you have B squared, which would help this one escape. Okay, so we could make that one escape, we could make that one escape, but unfortunately we have to put the two middle bits together and make it worse than what we started with.
Multiply by the conjugate?
No, we haven't got a conjugate. What else? What else could we try? Yeah, the pressure. 2 roots on the same side. Ugly. Painful. Doesn't that solve the problem? Just get rid of this guy. Haven't changed anything, have I? I've just moved it over. Can you square this side now and let the root escape? Yes. Can you square this side? Well, you're saying no, but why? Would it become unbearable, or would it might not disappear the root completely, but it won't be an ugly square root. Do you see what I mean? Because when you square this, that's okay. When you square that, that's okay. When you put them together, you get 9 square root, which is a hell of a lot better than square root times square root. See the difference between the two lines? Now, square both sides. Therefore, x plus 2 squared plus y squared. So imagine I've squared that. And now I'm squaring that side. Equals 9 squared, 81. Minus 2AB. 2 times 9, 18 times the root. So it's 18 of the root. Plus b squared, which is the square of the square root, which means no longer do you have a square root. Yep. Now it's just algebra. Let's expand. X plus 2 all squared is x squared plus 4. Oh, plus 4x, sorry. Yeah. Good. plus y squared equals 81 minus ugly square root plus x squared plus 2x plus 1 plus y squared. Good so far? X squared, they're on both sides of the equals, let's cancel. Y squared, both sides of the equals, cancel. Let's fix some things up. What are we going to get? Number one, I don't like this being negative, so I'm going to bring it over to this side. Yep, I made that positive. Equals, I've got 81, and I've got 1, so 82, and I'm going to take away 4, so I've got 78. I've got a 2x, and I'm taking away 4x, so it's minus 2x. Check through the lines. I'm going to divide by 2 just because it's too hard for me to work out in my head. 78 squared and 38 squared, whatever. Not that I can work out the other ones, but we'll just... Yeah, divide everything by 2. 18, 78 and 2. Now what? Remember, I'm trying to get x's and y's together to find a relationship.
First side by 9. And square.
Yeah, what would you get rid of first? The one thing I don't like is the square root, yeah?
Square.
So square both sides? Okay, so we square both sides. We're going to get 81 bracket x plus 1 squared, x plus y squared, da da da, equals 39 minus x all squared. 39 squared. I don't know. Someone? Press the calculator. Just under 1600.
1521.
Huh?
1521.
1521. Minus 78x plus x squared. So I've done difference of two squares, perfect square on this side. Yeah. Because I watched the little look on the face at home. So, alright? 81. X squared plus 2x plus 1 plus y squared. 1521, 78x, x squared. Told you, go for boards and boards. 81x squared plus 162x plus 81 plus 81y squared is 1521 minus 78x plus x squared. God's sake, what is it doing? Let's wipe off this x squared. That comes to this side, 80x squared. Plus, is there any other x's? Okay, 162 plus 78, 240x. Yep. Plus 81y squared equals, I'm going to take this over to that side, 1521, take away 81, 1440. Do you recognise that? Not yet. It's time for our favourite, complete the square. On this, 80 x squared plus 3x. Shall we do it at once because I'm running out of room? Okay, I'm going to make a big bracket here. Took out 80. I'm now going to complete the square of this. Check. Half of 3. 3 on 2. Square it. So that gives me 9 on 4 minus 9 on 4. Good? 80 bracket x plus 3 on 2 squared. Now, watch. I'm going to multiply these two together. So it's 80 times negative 9 over 4. Which is minus 180. X plus 3 on 2 squared plus 81y squared. Add 180 to the other side is 1620. Still keep going. Divide everything by 1620. And it equals 1. That cancels to that 20 times. What is 80 over 1620? It's 8 over 162, which is 4 over 81, which means it's 81 over 4. True? I cancelled the 2's, I divided by 2, so that's 4 over 81. So 4 over 81 is the same as dividing by 81 over 4. The reason I've put it like that, you said it was an ellipse. That's the form of an ellipse. X squared on something plus y squared on something equals 1. The picture is, there's negative 3 on 2, the centre, right? Centre. This is my radius in the x direction, which is 9 on 2, so it goes to about here, and it goes to about here. I'm just doing this very roughly. Right? And this is the root of 20, so it's 4 point something, so it's up here.
So how do you draw an ellipse?
Huh?
We actually don't know how to draw it.
Never seen an ellipse. Didn't do it in methods. No? Okay. We touch on ellipse again properly, but general form is this. Okay? This is the general form of an ellipse that you might have touched on last year. And the A, the difference between an ellipse and a circle is you've got different radius. A circle is nice, it doesn't matter which direction I go. An ellipse, just think about it, you stretch out this way more than this way. So when I talk, it's not really a radius, but when I talk about in the centre, A is your maximum distance here, and B is your maximum distance that way. That's what makes it an ellipse.
How do you tell what's going to be the radius? I mean, or the
Square root of that is, and the one that's sitting underneath the x is the maximum sort of radius in the x direction from the centre, and the one sitting under the y is the maximum direction in the y.
So in that case it would be 9 on 2 and...
Yeah, so this here would be 9 on 2, and this would be root 20. Right, and the rest are just matches to curve.
So you know how it's y minus k? So would that I mean, if you get y minus 1, then would that be what?
That whole thing would move up 1.
Upwards,
Yeah, just like a normal circle, normal translations. Yeah. Yeah. Do you like that? Do you want me to show you how to do it in one line?
You joking?
No, I'm not joking. I'm not joking. It takes a little bit of work, but it's effectively one line. This is where people get annoyed. What was the original thing? Z plus 2, Z plus 1 equals 9. Correct? So,
Was that it?
is that it?
It was so long ago.
It was so long ago, about 20 minutes ago, that was the equation we started with. Draw your axes. Yeah? Physically, what did we say this represents? It represents the distance from me, the moving point, from two set points. Mark them. There's -1, there's -2. Whatever these two are, right? You mark them on your answers. You then mark the midpoint of those two. -3. Check. This is our total distance. This is the total length of string that I've got between Fiddler and Daniil. My arms are only 9 metres long. So it doesn't matter what I do, I can only stretch out 9. Yeah? So from the centre here, the furthest distance I can go is 4.5 from the centre. So here, imagine going out 4.5. So for -1.5, this takes me to 3. And this takes me to -6.
So are you adding? What are you adding?
To the centre.
What are you?
Half of this. You look at whatever that number is and you do half of it either side. Because think about it. If I was standing here, how far am I away from there? 4 units. And you're standing here. How far are you away? 5 units. Together, 9 units. If I'm standing here, you're 4 units away from me. There's 5. Total, 9. Okay? Total distance between the 2 points has to add up to that. So all I do is cut it in half and use half that distance. Then, somewhere up here there's a point. And if I was with my string perfectly in between 2 people, the length of my arms have to be 4.5 each. Because I've only got 9 to play with, and I'm directly opposite. Again, all you do is use half this number. So that's 9 on 2, yeah? 4.5. This is a half. You already know that. There's a Pythagoras triangle. That squared minus that squared gives you this distance. 81 on 4, take away 1 on 4 is 80 on 4, which is 20, which means that distance there is the square root.
It's not 80 or 4.
Sorry?
It's 80.
It's 81 on
77
4.
or 4. Wouldn't it be 77 or 4? 81 or 4 minus 1?
Minus a quarter. 80 on 4.
Oh, it's half. Okay.
It's a half, yeah? That distance there is a half.
I thought it was minus 1.
So, you've now bypassed all those 3 boards of work and come back to the same picture. And then from here, you write your equation. It's in that form. X, what was the centre? 3 on 2. What was my radius? 4.5, which is 9 on 2, which is 81 on 4. The y didn't move anywhere, so it's y squared. What was the distance? Square root 20, square that, get 20, equals 1, move on to the next point.